Hey guys, welcome to the third session of the collaborative Android study jams presented by DSC PS University RR campus and the Electronic City campus. I'm Shubham. In today's session, we'll be looking at Unit 2 of the prior programming experience. And wait, am I presenting? Can someone confirm? All right, Irfan's here. Nice. Nice timing. All right. So yeah, we'll be covering Unit 2 of the prior programming experience. So specifically, I'll be covering pathways 6 and 7. Irfan would be doing 8, 9, and 10. So to give an overview, so I'll just open this for a sec, just give you an overview of what I'll be talking about today. So in last week's session, we looked at, fragments and how to navigate between fragments. And we did a little bit of data binding. And so in today's session, we'll be looking at view models and live data and how to, use data binding with view models and live data. And pathway 6 concludes with live data transformations. So for today's session specifically, we have sort of built an app to demonstrate all these concepts. Let me close this. So to understand view models, let me show you the app we've built. Right. So over here, as you see, this fragment over here, it has a couple of buttons and a couple of text boxes. So the button plus over here, what it does is it just increments the value of the text box over here. The minus button decrements the value, pretty straightforward. And previous takes you back, next takes you to the next fragment. We'll look at that later. So coming back over here, so we have, let's just set a value like 4, okay? And now suppose you want to change the orientation of your device. What you would do is just rotate left, and yeah, you click on that button to change the orientation within the app. What you'll notice now is the value which was 4 has become 0 here. So you've basically lost, whatever data you had, it's completely gone, and now you have to like rebuild it. So again, if I give it 4, or let's say 3 this time, and I change the orientation of my device again, click on this button, I lose 3. So the thing about fragments is every time you change the orientation of your device, fragments are destroyed and they're rebuilt, using the new orientation. So during this process, the data which is stored in the fragment is also lost. Hence, you see your data resetting to the value 0. Now, to overcome this, we use the concepts of view model and view model factory. So let me give you a demonstration of how view model and view model factory works, and then I'll explain it. I'll explain the code of it. So it's the same layout as the previous one, just the pathway number changes. Again, let's give it some value. Let's make it 6 or 5. All right, now the value is 5, and let's change the orientation again. Click on that button. As you can see, the data is preserved. All right, and now let's say I give it some more values, or keep changing it. Let's say 2. I change the orientation again. Rotate the screen. The value 2 remains. So this data consistency is achieved using the concepts of view model and view model factory. So to understand view model and view model factory, basically, you can divide your code into the UI elements and the view model element. So the UI element over here would be, you could say the UI element is the fragments over here. So the fragments will basically just display your data. In our case, it'll display the numbers, 1 to 10 or infinity, whatever. And view models, which handle, what you can say, it handles the value of the data. It sets the value, it gets the value, all that, all the manipulations of the data is done inside the view model. So let me start from the beginning, okay? Let me go back to this fragment. So we're reusing the concept of view binding, storing it in a binding variable. And yeah, here we're getting all the IDs and storing it in binding. And yeah, we're just setting some actions for the buttons over here. That's the previous and the next button over here. Wait, let me pull it up. So yeah, previous goes back and next goes to the next pathway, or next fragment basically. That's that. And over here, you'll see that we are not quite using the idea of, the UI element and view model element. Basically, all the data manipulation and display is done within one class. So you can see you're getting the value into the pathway 6.1 fragment. You're incrementing or decrementing it, and then you're setting it to display. So if you go to pathway 6.2 now, you will notice we're using, first of all, we're using a new variable called view model. I'll explain how this works. And yeah, so in view model, you'll notice that we're not incrementing and decrementing over here. We are just displaying it. And the display also is actually taken care by data binding. So basically, we're just defining variables here. That is all we're doing in the UI element. Now let's look at the view model. So to use view models, you want to use two types of classes. The first type of class is called live data, and the second type of class is called mutable live data. So live data is, again, a lifecycle aware class, just like view model. Basically, it does not get destroyed when the orientation changes, just like view model again. And what you want to do is every time you get value to your view model, you want to store it in a live data class or live data object. And so once you store it over there in a live data object, so in our case it's called number. Let's see what I've defined it. Yeah, the live data number is actually storing the value of the text box over here. So 0 is by default present in number, okay, when the fragment loads. And the thing about live data is you cannot edit live data. You can only read. So for the purpose of updation and all that, you have to use a separate class called mutable live data. Now, mutable live data is something, it's the same as live data. It's again lifecycle aware, but you can edit. So when you're updating the value of number, you first update number, and when you want to read the value of number, you use a get function, a getter function, and get it from the underscore number variable. So yeah, so yeah, now all the data manipulation functions are present in the view model, and yeah, the UI controller part, which is the displaying part, is over here. There's nothing else left. So now let me show you the XML. So here's another concept that we're implementing, which is called data binding for layouts. So in order to implement this, you create a data variable, you could say, and inside the variable you define the name. So I've defined it as pathway 6 view model. You could give any other name. The name, this is just a convention I'm following. And the type is something you need to follow. So since I'm making a pathway 6 view model class variable, it has to point. So when I say it has to point, it has to be of type pathway 6 view model. So this is the class I just showed you over here. Yep, this one. So I'm making a data binding variable of type pathway 6 view model, and every time I want to access access a function or a variable of pathway 6 view model, I just, let me get you an example. Oh wait, I'm in pathway 6.1. What am I doing here? Yeah, pathway 6.2. So yeah, you define a, wait, let me scroll. You define a variable here, and every time you want to say increment your what do you call it, the value in the text box over here, you use this expression here. So this expression over here is called listener binding. Basically, you can directly access a function of the pathway 6 view model variable, without basically by separating the UI controller and view model as two separate classes. So there's that. So every time I click on the plus button, it calls the increment function, and it's the increment function. I think it's below. Oh no, wait, I'm in the wrong class again. So yeah, I go back to my increment function. So here's the mutable live data. I get the value. I append a 1 to it, basically increment by 1. And yeah, that's it. So I increment the value by 1. I'll explain what this code does a bit later. Okay. So every time I increment, I just take the value of number and add it by 1. And when I display it, which is over here, so since when I'm displaying it, that means the fragment is live. It's in terms of yeah, it's live. So what you want to do is, oh no, I lost it again. Yeah, it'll use the get function, and it'll get the value of underscore number. So underscore number is actually number plus 1 right now. So the value gets incremented, and when I go back, go back to the text view, I use another listener binding expression and just display number, right? So this is how the increment operation is happening. I'll string format is over here. I'm just telling I'm just formatting it into a string. I'm displaying a number in form of string. That's basically what I'm doing. Let me just show you that. Number format, yeah. So I'm just telling the compiler to expect a number over here. That's it. And let me go back. So yeah, same way the decrement operator works. You get the value of number. Underscore number stores the value of number minus 1. And again, since the fragment is live, it automatically updates the value over here, because the getter function will get the value of underscore number and it'll be displayed over here. So that's the concept of view model and data binding layouts with view model and live data. So another concept they've taught is called transformations. So I technically haven't implemented transformations here. I'm just telling the text view to expect a number here. But what transformation basically does is, let me go back to the view model. So what transformations basically does is, it takes the live data and converts it into a string object, or yeah, basically a string object, so that you can display it on your layout. That's basically what transformations does. And yeah, that summarizes pathway 6 as a whole. I should have covered all the concepts. Let me check the time. Right, we're good on time. So yeah, we went through view model, live data. Oh yeah, observers. I forgot to explain that. Let me, oh no. Let me close this. So one functionality that I implemented in pathway 6.2 is, let me go back here to pathway 6.1. So you see the value over here is 0 right now. And if I keep clicking on minus, it goes negative, all right? But over here, if I click on minus, it gives me a toast saying the number cannot be below 0, and it doesn't let me decrement anymore. So the way I'm implementing this is, 1 second, go back to my view model. So I've created another variable over here called event below 0. It's a Boolean live data variable. And so yeah, what this variable does over here is it checks every time the value goes below 0. If it's below 0, yeah, in decrement, I think. Where's decrement? Yeah, so in decrement, I check if the value of number is less than 0. If it's less than or equal to 0, I call the method on 0. And on 0, wait, where's on 0? Yeah, on 0 basically tells even below 0 is set to true. So every time the value is set to true, yeah, I need fragment 62. Using my view model variable, which I've defined over here at the top. Yeah, that's the declaration. Initializing it over here. What I'm doing is I'm using the concept of observables. Now, to understand observables, wait, let me pull this up again. Design. So observable is something, that can be seen by the user or can be interacted with. So over here, our observable is, the text box over here, the value inside the text box, and the observer is basically our code or the fragment at the back. So let me open the fragment. So over here, yeah, over here we're telling it to observe the value of even below 0. If the Boolean value is set to true, it calls the function below 0. And below 0 is basically a toast function, it just tells the number cannot be below 0. It's basically what we saw over here, right? So view lifecycle owner, forgot to mention this as well. So when you're using fragments inside activities, so you have two life cycles going on. One is the views activity, the activities life cycle, and the fragments life cycle. So you have two life cycles going on simultaneously, and in order to use the observable function properly, one thing you need to do is define the lifecycle owner over here. So the lifecycle owner over here is the view lifecycle owner. Wait, have I defined it? Yeah, I should have defined it somewhere. So yeah, basically what you're telling it is that the fragment is the lifecycle owner over here. So there's no confusion, during runtime that which activity or which fragment owns the current lifecycle. So that's how the observable function works. Yeah, so that's pathway 6. Going to pathway 7. So in pathway 6, we saw that how to keep data consistent when you change the device's orientation, like from landscape to portrait or portrait to landscape. So yeah, this is something I already demonstrated. Now, suppose I close the app, all right, and I bring it up again. Yeah, you'll notice that it reset it to 0. So I've basically lost my data after I closed it. So in order to implement that, keeping data consistent even after the app is closed will be, that's basically the objective of the pathway 7. So in pathway 7, we'll be looking at room databases, we'll be looking at coroutines, and we'll again go through the idea of recycler view. We'll look at data utils, which is a class specifically designed to optimize recycler view. And we'll be ending it with grid layout and how to make, items of the recycler view more interactive. So start off. By the way, this code will be available on GitHub online if anyone wants to see it. I'll share a link on the Discord channel. So yeah, if anyone wants, I'll share the link. This is done. Right. So let's again let me give you a demonstration first. Oh no, wait, let me start from the beginning. So I'm actually reusing the same app as they've given in the pathway. Where is it? Wait, what are the two versions of it? Anyway. Okay, this starts right over here. I don't want that. Right. So over here, you have again a couple of buttons, a text view, and let's see what happens when I click on start. So when I, all right. Okay, turns out it doesn't work. Let me, nope, wait, let me keep it on. Let me just build the app again. Maybe it'll fix it. All right, so let me clear that. Right, so let's start the demonstration. So I click on start again. So you can see it's doing something. Let me click on stop. I'll just pick this for now. And let me click on it. Right. So now if I close this app, it's back, you know, and I can keep doing this how much ever time I want. It's going to keep saving it. Right. So that's the concept of databases over here. So to understand database, specifically the room database, which is a type of, you could call it a wrapper class for the SQLite database present in Android. So it was actually written in Kotlin and simplifies a lot of work, you know, to extract data, read data, and delete data, all that stuff. So in order to implement a database, we'll be covering a couple of things like entities and queries. So to start off, over here, as you can see, we have a class definition, a data class. We're adding an annotation called entity, and we're saying table name, daily sleep, quality table. So what this line over here does is it tells the the build compiler that this is a class. It's of type table name. The table name just tells the table name. And over here we have a primary key, couple of columns, and again in columns you can give the name, and yeah, here you define the type. So int, long, yeah. So this is, wait, let me get paint up. So that was a table, okay? In a table, you'll have a primary key over here, right? Primary key, and the rest are columns. So that's basically sleep night over here. What sleep night DAO is, to understand DAO stands for data access objects. So it's an interface which accesses the sleep night table, and you can basically insert data into it, update, get data, clear data. You know, you can define your own queries and do it. So by default, you have the insert function, the insert annotation, and everything else. You have insert and update, and everything else is defined as a query. So again, through the annotations, you know, for queries, through the annotations, you define what kind of query you want. So for people familiar with, you know, DBMS concepts, select star from daily, where night ID equals to key, what it does is it basically gets all the rows where the night ID is equal to the given key over here, which is passed over here. All right. So like that, you know, you have a couple of queries. And so yeah, this is basically the interface which will access this table over here. So sorry about the drawing, but yeah. And finally, we have the database. So a database is basically, you can have a bunch of tables defined. So for our example, we just have one table defined. Uh, the the database contains the table. So here you'll notice, yeah, there's actually a lot of comments, but I'll just explain what happens with the companion object. So a companion object will basically instantiate the sleep data class. It'll create, let's see, where is it? Yeah, it'll create an instance of the database. Specifically, not the database. It'll create an instance of the class. Oh no, wait, it is the database. So yeah, it'll create an instance of the database, and what you're telling it is to create a instance of the database, and you define a couple of functions over here, like the fallback, destructive, migration. What migration basically is suppose you have your table, and in the future you decide to add a column, or you decide to delete this column over here. So the schema of the database changes. So what you're telling by fallback to destructive migration is destroy the entire table completely, and rebuild it with the new schema. So all the data is preserved in that way, but you're restarting fresh. And yeah, again, build just tells you to return an instance of the database. There's a keyword over here. Where is it? Yeah, volatile. So what volatile tells us, it's something that should not be stored in cache. When it is compiled, the compiler knows that this function, this variable over here will not be stored in cache, and will always be read and wrote to in memory. So that's volatile. Synchronized, this basically means this function can only be accessed by one thread at a time. So in high-end mobile phones, you can say they'll have multiple processors, multiple threads, and you don't want what do you call multiple threads accessing the instance of a database at once. Then you might have data inconsistency because you have two different databases of the same type, and then the CPU won't know which one to access, and you'll have a lot of data errors. So this is actually a concept taught in operating system. In case you guys are in computer science, yeah, you'll learn about this soon. So yeah, this function over here basically returns an instance of the database. And yeah, so yeah, we've covered the concepts of room database. The next concept we'll be looking at is coroutines. So to understand coroutines, how do I explain? Do I have anything? Okay. Wait, how much time do I have? Okay, I'm running a bit short on time. So coroutines are basically, say you have multiple tasks to be done. You have task 1, you have task 2, you have a bunch of them to be done. So one way to do it is, multi-threading it. So you can do task 1 on one thread, task 2 on another thread, task 3 on another thread, so on. The other way to do it is use coroutines. So coroutines are something that run on the main thread, but they do not interrupt, the main thread's UI execution. So, this user interface over here, like clicking on start, stop, uh, all this is not interrupted by coroutines. Coroutines are non-blocking. So if something's running on the main thread, it'll let it run, and once it finishes, only then it starts working. So again, this is a bit of a concept of operating systems, but I'll try to explain as much as I can. So yeah, so coroutines are technically not multi-threading. Instead, they all run on the same main thread, except the only difference is if a UI task is running, it's given priority. So coroutines, they don't implement any sort of drawbacks in your app implementation in terms of UI. So to see coroutine working over here, let me open Sleep Tracker, I think. Right. So here you can see initialize tonight. So this is a function say you want to read from the database, all right? So it launches a coroutine. It gets the latest data from the database, and it stores it in a live data. I'm guessing it's a live data. Yeah. Oh no. Yeah, it's mutable live data. So it stores it in that. So that's how you basically implement a coroutine. Let me. Right. So on clear, this is something you guys have actually seen. So right now I have 3 objects in my recycler view. And if I click on clear, uh, this is actually implemented on the coroutine. So every time you say view model scope launch and define some function or some activities in here, this is taken into coroutines. So yeah, that's basically how you implement them. And yeah, that's pretty much about coroutines. It's very conceptual, and implementing it is really not that hard. So yeah, this is again live data with control buttons. We've already seen this in the previous example. Let me open a give it a minute. Right. So implementing live data with what is it? Live data with button states. So when I click on click, it goes to on start, and on start is basically telling it, that a button click has happened, and yeah, it's aware of the button state basically. So that's the main concept of using live data with buttons. So again, over here you can see the same thing is implemented on clear for on stop. That's the concept. Recycler views. All right. So to show you the recycler view, let me just go over the concept of recycler view. So basically, if you have a bunch of items on your list, all right, so you have 100 items on your list and you want to display them. So a basic way to display them would be, create a scroll view and display each item on that list, independently. So the problem with this is, you're spending a lot of data and resources to, come up with each item. So it's really computationally expensive, and you're not even using all the screen space. I mean, you're not showing all the data items at once. You're showing probably like 5 or 10 at once. So you don't need to load all the data items at the same time. So that is when you use the idea of recycler view. So the idea of recycler view is items will come and go from the screen, all right? You will only display the items which are presently on the screen. Everything off the screen is removed from the view. Anything that's coming onto the screen is added to the view. So this management of views and which item will come on the view is handled by three functions. Let me bring that up. Right. So yeah, the 3 functions are on bind view holder, on create view holder, and wait, there should have been another one. The third one is called get the size. All right, so it's a number of items on the list. So on bind view holder, what it does is it takes 2 arguments. It takes holder and position. Holder is basically the type of view group. So here our view group is pretty much defined as a recycler view. So yeah, it'll create a view for the recycler view, and position is the number of what can I say? The number of items. So over here you can see there are 4 items on my screen, and each item could again have a text view. It could have an image, could have another text, stuff like that. So yeah, it defines number of data items present in the view, and yeah, that's about it actually, about on bind view holder. On create view holder, what it does is it takes the position of the data item from the list, and the view group is again, the type of view group. So wait, over here, what's happening? All right, this is a bit of a modified version, text view holder. Yeah, I meant to talk about text view holder actually. So basically, what you're doing is you take the data, you create a view out of it, and you return the text. You return the view. So in our case, it's just a text view. So it'll return a text view holder with the view present in it. Yeah, that covers recycler view. Yeah, the grid layout. So what you're observing here is when I click on start, stop, let me get some elements here. So you can see that my elements are actually being stacked horizontally, and when there's no more space horizontally, it's stacked to the next line. So what this view is called a grid layout. And the reason why you want to use a grid layout is because in recycler view you either stack it vertically or horizontally, which is not really a good view, user space. So using a grid layout, you can actually utilize the entire screen. And the way this is achieved is by using a layout manager. So let's see where the layout manager is. I think it's here. So here I'm defining the adapter for the sleep list. The sleep list is basically the list of all items over here. I should have right. So I'm defining a grid layout manager object over here. So it takes two arguments. One is the context, which is the current activity. So I just pass activity, and then the second argument is their number of items horizontally. So it's called span count. So here I'm taking it as 3. We have 3. I could change it to 3, or I could change it to any other value, and it'll accordingly change over here. So yeah, that's basically it. How you define a grid layout for a recycler view. You just create the manager. So you create a grid layout manager, and then for the layout manager, you assign manager back. And let me see where sleep list is defined. It's a bit above, I'm guessing. Sleep list is all right. Sleep list is actually the recycler view, right? So yeah, once you basically tell the recycler view the layout manager is a grid layout, it'll automatically change the view for you. You don't really have to do much from there. Binding utils. So these functions over here basically, tells how to format the strings. By default, I think you get decimal values, so you can actually format it into a text. Yeah, over here, yeah, the concept of binding adapter. So by default, when you have an adapter, it converts any object into text, all right? But what a binding adapter does is, say you want to convert from one object type to another. So this is a really good example. So over here, you pass item.sleep quality. Sleep quality is an int, all right? So you get 0 to 5. And now you want to convert 0 to 5 into images. So it maps 0 to sleep 0, 1 to sleep 1, or that way. And basically you're converting numbers to drawables. So that's basically the idea of binding adapter. So I think I should have covered that. Headers, all right. The concept of header is basically, a recycler view which has some sort of display on the top. So here our display on the top is results, and if I clear results, all right, it stays. Basically, it just gives me an information about what my recycler view is representing. Nothing more than that. So yeah, I think that's about it. Let me let me just delete all this. It's unnecessary. Mm, yeah, thank you. I'll let Irfan take up pathways 7, 8, 8, 9, 10. Yeah,
Thanks, Shubham. Yeah, so I'll be continuing with pathways 8, 9, and 10. So let me stream my screen here. Okay, all right. So what we are going to be going through now is connecting to the internet, the repository, and your work manager, and then the final, which is your design for everyone, which is material design. So for connect to the internet and the repository and work manager, I'm going to be showing a couple of examples from applications that I've worked on. So let us first take an example of connecting to the internet. So let me just open up that application here. All right, yeah. So in order to connect to the internet on any device, so the old way of connecting to internet services would be through a function by the name of asynchronous tasks. This example over here, async task. So the reason async task literally means asynchronous tasks. So that means that operations are performed in the background. They don't have a, they're not synced to any operation. That allows you to load web pages which are heavy in nature, or retry for errors without affecting your application. For example, let's say you load up Amazon's application, you'll find that there's always something that's displayed. Even if you turn off your connection, it'll always show maybe an error message or something of that sort. It'll never hang, or it'll never just stop at the loading screen. That is because all of those operations happen in the background. Now, in our case over here, these are a couple of guidelines that Google wants us to follow. Asynchronous task is the old one. The new ones are community-based libraries. An example of this would be Glide. So Glide is over here. Let me just show that. Yeah, this line over here. So this is a module that is built by BumTech. It's used for loading images, and a library. It's used for loading images primarily, either from the web or from local storage. So an example of these images being loaded would be in my home page here, where I'm trying to load images inside. Let me just find that in here. Hold up. Workspace. Yeah. So here you can see an example of Glide being used. So every module has their own ways of loading data. So in our case, it's an image. So you can either load it from a resource that you've saved, or you can load it from a URL. That could be any URL that you find on the internet. So let me just explore this code lab a bit, and that will give you a couple more examples on existing tools that can be used. So over here, you can see a couple of examples, Retrofit and Moshi. So coming back to what exactly these two services do. Now let me go back into the example that we originally had. Yeah. So all data transmission happens as a string or in a series of bytes. Now, in your Android application, you'll have a lot of classes which denote data structures. For example, Shubham talked about DAO objects, right, which define a class, maybe a user with their attributes, those kind of features. So how do you go about converting data that is read in as a stream or a series of bytes or as a single line of, as a single string into objects that can be used in your application? So for that, one method is to create your own classes. So those classes would take in string data or a JSON data and convert it to the class object of your choice. For example, over here, this is us fetching the entire data that we need from a given URL. So we're taking a URL, opening a connection, getting data. Once we have that data in here, that is after we finish getting the data on post execute runs. I'm not explaining the details of asynchronous tasks because that is not a advised way to go about building or go about networking in Android. Nowadays, the best features is to use the retrofit and using Mochi. Those are the two options that you have. So, what retrofit does in short is this entire function here connecting to a service and asking for a particular resource is what retrofit does. So it allows you to connect to a RESTful API, and that response that it gives back, right? It can either be stored normally as a string or whatever array that you prefer, or you could use Mochi to directly convert it into an object for your type. For example, let's come in here and see this user class. So inside here, you see this user class has a lot of details in them. So a name, school, grade, UID, sheet ID, all of these other questions that are present. Now, if I want to convert the data that I'm getting into a user function like this, it means that once I get this object, I need to be able to map it into it. So if I go down over here, yeah, you can see that in here. No, where's that login? Yeah. So in here, once I get that data, I'm running it through a full series of operations here in order to convert it into the class that I want. So I want that string data to be a class that I can access and use. So in order to avoid us having to sit and create classes that extract data, right? For example, what's happening over here in on post execute, we're getting the entire response back, and then we are going through all of the response details. We are extracting JSON objects from it. JSON is another library that comes by default in here. So JSON objects, JSON libraries, these are again modules that you implement. So once you run those operations, you end up getting your particular object. For example, over here you're getting I'm converting it into an object, JSON object, and then inside here I'm getting a name by the ID. So Mochi allows you to do that entire operation just by a simple import. All you have to do is specify where the input is coming from. For example, let's assume that string S is our input here, right? So in Mochi, you're going to be taking in the string S, and then you're going to be assigning it to a type of object that you've defined. For example, user object. And then on the fly, that entire conversion happens, and you'll have a user object that is ready for use. So that is your retrofit and Mochi library in short, essentially networking in Android. Apart from that, there's a couple more things that I want to elaborate on. For example, coroutines and other operations like that. So the next part that comes in is our repository and work manager. Now, what do I mean by a repository? A repository essentially is the first stage of where you fetch data from. You can think of it as a cache in most cases. So let's say that you have a set of images that are stored and loaded into your database, or rather your online database, and you want to load them in your application. So when you start up, you'll usually have this a waiting time where in which it's fetching data. Now, how do you avoid that? Or let's say that you load images from a website, right? And what happens is you navigate to a different page and then you come back to the old page. If you don't use any caching, what happens is the image is loaded again. So you'll see another loading dialog that pops up, even though you were on that page a couple of minutes back. So in order to avoid that, we use caching, and a repository is a way to cache a lot of data. So it could be text, it could be strings, it could be images, videos, whatever be the case. So repositories are built off of your DAO objects and your room database. That is your repositories in short. They are extensions of your databases, rather your room databases. So coming to coroutines and these features that Shubham was talking about. So let me go to an example where there's a coroutine used here. Let me go into fragment settings. All right, over here you can see that there's a coroutine scope that's being used. Coroutines are ways of you to run operations on different threads. So, for example, let's say you have a memory intensive operation such as loading an image. Let's say it's happening on the main thread. So, let me open up this emulator here. So, if I had to load this image up, right, what happens is every time I press this button, I want it to load as quickly as it can. But I don't want it to slow down. For example, if I press this and I press this back, it should switch in immediately. It shouldn't say loading and then wait for it. The reason this switch is so smooth and that I don't need to wait for it to load is because this is running on a different thread altogether. So in this example here, we are running it on these are wait. Let me go to the image loading thread. That will be a better example. It's this one. Where is our loader? Yeah, so here you can see that I'm using glide here to load data in. Another example, let me go back to the original one. Yeah, so here I'm performing a certain function, but I know that the function is intensive. It'll take some amount of time and memory to complete. Now, in that moment, in that time, I don't want it to sit and show a loading screen. In order to avoid that, what I do is I push it on to a different thread. So there are different types of threads that you can do. So let me just show you all the ones here. So dispatchers dot, yeah. So these are the four major types of threads that are available: default, IO, main, and unconfined. I'll talk about the first three primarily. Unconfined is more advanced. So default thread is the thread on which your application is already running. That is the thread which it will default to for any background operations. Now, the IO thread is a thread that is dedicated to any form of IO operation. What do I mean by IO? In Android, by IO, I don't exactly mean user input or screen interactions or UI interactions. By IO, I mean disk writes, disk reads, those kind of functions. For example, let's say you're accessing your room database, right? In that case, you'd use the dispatchers.io to perform your function. Let's say I want to run something on the main thread. That is, let's say I want some form of animation, like, for example, if I start this animation pops up. Let's say I want some kind of animation of that sort. In this case, what I need to do is I need to run it on the main thread. The main thread allows me to synchronize my operation, but it also gives me the benefit of not having to show a loading screen or any form of delayed or latency. Now, main, if you're performing small operations, main is perfectly fine. But if you try to perform, let's say, a database read or a database write on main, right, you will see the performance impact on your app. You'll see it start to slow down a bit when it's trying to read data, that kind of stuff. So that is your coroutine scope. It's coroutines and your coroutine scope. So basically, they are, if you guys have worked with Java before, you would have heard of this concept of threads and runnables and those kind of functions. Coroutines are a more advanced and a better way of handling threads, and they give you the same amount of operation with less boilerplate code. So now let me talk about work managers. So work managers essentially allow you to perform operations at a specified during a specified interval of time, or recurringly occur at a certain interval. So let's give an example of that. So let me go into this, and no, I think it's over here. Let me find my work manager. Yeah. So in here, you can see that I've named it as a daily sync receiver. So I want this operation to happen daily or weekly or any time that I can make it happen. So what happens is, over here, I set the constraints. The constraints are the requirements that should be met for the work manager to execute. So let's say I want to run some operation like maybe upload data to the cloud. In that case, I need to make sure it's connected to the cloud. There's no point of me trying to run an application when there's no network connectivity. So over here, what I'm doing is I'm creating a constraint and setting that I require the network to be connected. And then I build the constraint. Now, the next thing I do is I go and create a work request. A work request is the work that needs to be done. So over here, you can see that I'm doing a one-time work request. So this means that this work action happens only once. It doesn't happen more than that. and then I'm giving it the class of the worker. So what work do I want it to do? The worker defines it. This I'll come into in just a bit. And then I'm setting the constraints, and then I'm building it. Then I'm calling the basic work manager function, which you can import directly, androidx.work. And then work manager.get instance, given a context, I'm going to add it to the queue. So once I add it to the queue, the device will make sure that this operation executes, and that's a guarantee that the device gives you. So this is a way for you to give guaranteed operations to perform at certain intervals. For example, backups daily, a scheduled activity, those kind of stuff. So let's go here into posture activity worker and see what that does. So in here, let's go in here. Yeah. So inside my worker, you can see that when I start it, I'm loading my repository. And then after I get my repository, there's a function by the name of do work. So in this thing, what happens is I am calling a function in there to update the daily activity to the cloud. So when this function runs, right, it'll then go back to my data repository, and inside here, it'll run a function that uploads it to the cloud. So let me go back here, update daily activity to cloud. So it's going to get data, and then it's going to push it to the cloud over here. I've linked it to Firebase, and that's what's happening here. Now let's go and give another example of maybe a recurring work activity. So let's go down here. Work manager. All right. So now over here, you can see another example of the work manager. In here, again, I'm setting constraints here. I need to make sure that the network type is connected. After that, I want it to be a periodic work request. So I want it to happen at regular intervals of time. So in here, again, I'm going here, declaring a posture activity worker class. The repeat, but in this case, you'd find that there's something different. Over here, I define the repeat interval. So I want it to occur every 15 minutes. So time repeat interval is 15 and the time unit is minutes. Note that this is not guaranteed. It'll either do it at 13 or it'll do at 14, 15, 16, 17, but it will do it. It'll guarantee that it will do it given that the device has enough power and that the device is not in sleep. Those are two considerations you need to keep in mind. Once that is done, I'm giving it a tag so that I can identify it easily when I'm debugging. And then you would find another thing that says set backoff criteria. Now by this, what it means that what happens, since it's a periodic request, right? I want it to happen. I want it to keep a track of history. For example, let's say I'm uploading, initially I upload 1, the next time I want to upload 2, third time I'll upload 3, and so on. Now, if let's say the first request fails and then I just upload 2 directly, I don't want that to happen. I want it to be sequential with all the data in it. So in that case, I have this backoff criteria here. This means that if any work request fails, for example, the constraint is not met, or if the internet connection, this connection wasn't successful, or I get some error while trying to execute, this will make sure that it'll again occur. It'll again make this this worker run in that particular amount of time. So here you can see that backoff policy is linear. It means that let's say this work request fails at 5 minutes. And now when I want it to run at, let's say it fails and then I want it to run again. What will happen in this case is that it will linearly start growing the delay between items. So the first delay would be 15 seconds. The next time it will be 16 seconds, 17, 18, 19, 20, and so on. There's another one by the name of exponential. Exponential means I'm going to exponentially delay the backoff period. So it'll go from 5 to 15, 5 to 25 to 125 and so on. It'll keep going up all the way exponentially. And then in here, you define the initial time of delay. So it could be 1 second or whatever you want. In here, I've defined the minimum backoff time that has to be tried. This, you cannot go below this particular limit, even if you define your own value. Let's say you put 1 millisecond, it won't do that. The minimum value that you can choose is this one, and the value is specified here. And then the time unit, we want it to be minutes or seconds or whatever. Then I'm setting the constraints, building it. Again, I'm calling the work manager, getting an instance of it. And over here, I'm enqueuing unique periodic work. Now, what do I mean by unique periodic work? As I said, let's say I want to upload 1, 2, and 3, right? I can't have it being overwritten. So I need 1 to show up in the database, then 2 to show up in the database, then 3 to show up in the database. I can't have 1 just disappear and then 2 and 3 show up. So all of those all of those data items are unique. They are not duplicated. So NQ unique periodic work means that every time this worker runs, right, every single instance of the worker running will have a unique ID and will make sure that that executes. So over here you can see that I'm using a replace policy. So this would essentially say that uh, if there's a new worker queue that's come up, let's say there's two or more workers that are lying up and they're unique. If there's one that has not executed, this will say that okay, you can replace the old one with this new one. So that will be useful in, let's say, a counter of that sort. Give me a minute. Okay, sorry about that. Yeah, so what happens here is that in my case, this worker is essentially a counter of sorts. So let's say I have the initial counter was 1, and then the final, when I keep adding 1 2 3 4, it becomes, let's say, 8 or 9, something of that sort. There's no point of me uploading 1 and then uploading 8. I'd rather have it either upload 1 or it should upload the sum of whatever worked so far. In this case, I'm using replace. But let's say I wanted it to be unique, right? I don't want it to be replacing. So such that I wanted to upload 1, then 2, then 3, then 4. Then I use the word keep. This will keep the old work as is, make sure that that completes, and then it runs the new task. So that is your two types of queuing your work. And then I'm putting in the work request that I want, and that is your operation basically complete. So your work. Let's take a look at the work manager running live. So let me just pull out the tag here, go into the logcat, paste it in here. All right, so you can see that this worker is already run 2 times while we've run the application. Let me start it up again. And there it goes. So you can see that the worker result was success. So it successfully performed the operation that I told it to do. Now, if what work it was doing, let's take a look at that. Work manager was over here. Yeah, it is running the posture activity worker. So let's go in here and take a look at our worker here. So you can see that it's running the update daily activity to cloud. So let me go into and see the tag in action now. So over here you can see this is happening. Starting work, work completed. All of this happens in the background. So when I press this, starting work, work completed. And then by work completed, it means that it's gone to the function, it's successfully executed it, no errors, and then it's throwing a success message back. So that is your workers in short. So now let me go here. We've covered repositories, we've covered workers. Let me go back here and let's talk about design now. So before we start into design, let's go into this site by the name of material.io. And then let's head back in here. So material design is a set of guidelines that have been put in place by multiple companies, including Google and Apple, and they've worked together to come up with this material design guideline that is used extensively on all mobile devices and platforms. Its core philosophy is to keep things clean and smooth, and you can build amazing looking apps off of that because those companies have done the work for you in setting the baselines of what looks good and what does not. And then on top of that, you can end up customizing how your app looks, how the button looks, just by keeping those basic structures in mind. For example, a button should look like it should be closer to a rectangle rather than a circle. Basic guideline. Those kind of features are explained rather. So let me go here and let's talk about styles and themes. So let's jump into the styles and themes that we have over here. Let's head into values, and then you'll find a section called styles. So over here, you see that there are a set of styles that have been defined for this application, each of which cover a particular object, a particular type of data. For example, let's head into this over here, fragment header text. So by definition, it's a style that is there for all fragments, and that's the header text that shows up. For example, in our application, this is it. This thing, if I open up another page, for example, you'll find that this remains constant. And then all those things remain the same. So coming back here, you can see that instead of me defining the font and the size in every single page, right? Let's go back here into settings. And then in here, let's head into the code view. You can see that up top over here I have a text view. So in here you can find there's nothing about the color, the size. There's nothing about there's nothing about the what do you call font. There's nothing about the color, text size. None of those attributes are styled here. The only thing I pull is style fragment header text. Now, when I go back to my styles XML file, in here you can find that everything is defined. My color, the size, the family, the font family being used, the font being used, all of those features are defined. And all I need to do is just put that line in and everything falls into place. That is one advantage of styles. Now, if you want to implement something from the material background, you want something to follow along with the material theme, right? All you got to do is make sure that the parent that you're inheriting from is the material guideline. So by default, you'll have, if you type material here, you'll see a lot of components show up. So these are all the material libraries that are available to you. So how a headline should look, how what do you call, a button should look, how should a alert look, all those things are defined for you, and these things pull off of that. So let's go and give an example of headline one. Okay, let's take text experience. Yeah, let's use the material headline here and zoom in. You can see that the font has changed. It's not the same font anymore. Now if I go back and if I remove this and go back to my app compat text view, a font's gone back to bold. So those are the kind of things that you inherit from a base class. So your material guidelines, you can just inherit off of them and then add your custom flavors on top. Or alternatively, you can also do this. You can just head in here. Let's say we want to add another button. Let's put it in here. And now when I go down here, you will find that the style can be defined. So there's a widget app compat library. There's a library over here. There's Android. And if I keep scrolling down, I think, yeah, there we have our material buttons. So widget.material.button. If I select this, I think the color hasn't changed because maybe it's something else. But yeah, so that means that all the guidelines of the button, the text size, the font size, the corners of the button, all of them are defined and they fall according to the standard that is defined in the material guidelines. So these are your styles in short, essentially allow you to duplicate features effortlessly. So let's head into the next section and talk about material design in short. This is the homepage of the material design doc. So you can see that it's been built and it's supported by Apple as well. If you go down there, you will find Apple's mentioned somewhere. So these give you the basic tools you need to build apps that fall into these guidelines. So they cover the principles of how to design layouts. They cover the principles of how to design components, even icons. You have a lot of icons available. Let me open up all these tabs and we can take a look through that. For web as well, if you want to build a website, they have components for that. Accessibility guidelines. Let's say you want to make sure that text is readable for all devices. You want to make sure that it's accessible for handicapped users. Let's say you want to make sure that haptic feedback is enabled. Those kind of stuff are all are explained in these guidelines here. And then developer tutorials to teach you how exactly you can go about building these things. So this thing you can check out on your own time. I'll be covering these top 3. So in icons, you can find all the icons that you could possibly use in your application. These don't cover all the icons that you could use, but they cover a vast majority of the ones that you could potentially have or want to have in your app. For example, a shopping cart button or a add to drive, something of that sort. All you got to do is select it, select the type of icon you want, the color, whether you want the size of the icon. Let's say you want it for Android. Then you can download the SVG or the PNG format, whichever you prefer. And then you have different ways of coloring them as well. All of these are filled in for you, completely free for use. Those are your icon, and you have design principles as well. So these are something this is something you can use if you want to go ahead and build your own icon. So it'll talk about the dimensions, what to do, what not to do, how to round images, icon sizes, all those kind of stuff. So now, next thing is coming into your design. Design has a lot of features inside here. You have the environment, how to make the layout look like, how do you want the navigation to be. Let's head into layout. So in here, they'll talk about how to make it intuitive and predictable, how to let it be consistent. These kind of things come very handy when you want to build a killer app, and you want to make sure that it looks good. If you follow these guidelines, you're guaranteed to end up with an app that looks amazing. It may not be working the best, but it'll look amazing. That's what's guaranteed if you follow these guidelines to the dot. And you can always add on to them. They even have tips on how to go about with motion, for example, over here, how to make it look fluid, how to make it look clear. For example, over here, you can see uh, button tap right here. So these are examples of how to make it fluid. There's your motion, and then come your components. So you would have seen a couple of examples in the code labs about app bars at the bottom, top bars, bottom navigation bars, floating action buttons. That's a code lab that you would have done. So all of these have styles that you have to adhere, rather styles that is preferred to adhere to. For example, over here, let's head into floating action buttons since we've already done that. And then when you come in here, you can see a basic design of it. This is by default the design that comes when you just import a floating action button. So your behavior guideline is already met, but they you can place them anywhere you want, right? But the reason this is there is to make sure that you follow the guidelines and make sure that you build something that is very accessible. Accessible. For example, you don't want your floating action button to be somewhere up here, pretending to be an icon, pretending to be a menu button. So over here you can see an example of these kind of features. So showing that put one menu icon, one floating action button, and here they're telling you not to put too many floating action buttons. If you look at it, this screen feels a little heavy. So it doesn't come off as a polished, clean screen. It feels like it's a little out of place. That's because of the depth and the shadow effects that floating action buttons add. Now, if you replace this with normal buttons without the shadow effect, this will be completely fine. So those are just guidelines that tell you how a user would perceive the app as. And then here you have the anatomy, the dimensions if you need them. Let's say instead of plus icon in the middle, you want your own custom icon. How do you go about doing that? You define an icon according to the sizes that they defined in here. And then once you do that, you can just import that image in and have it used in place. So another example is don't use this buttons or badges on top. An example would be it's not clearly visible. Even on this large screen, I'll probably have to zoom in and then it looks a little legible. But if I go back to my normal size, it's on a glance, you can't even make out what it is. And then over here, more icon dialogues on what to use, what not to use. So those are your basic material guidelines in short. So those are essentially by design for everyone. They mean that your application should look good to every person and be used by everyone. So if you come down and design for everyone, you'll find accessibility features as well. So let me just start up the code lab here to explain some code. So for example, let's say you want to add support for languages. You want Hindi or Kannada, whatever you want to be displayed in the application. How do you go about doing that? Let's head into our application. We'll give you an example of that. Let's close. Yeah, okay, let's get in here. So now, where's my, yeah, layout? Let's say, let's go to login. Not this. Activity login, yeah. Okay, so in here, you can find this text, right? Now, if I go in here and if I take a look at this text, you'll find that it's not hard coded. It's linked somewhere else. So it's linked to string login description test. So now when I go in here, you can find the entire list of strings that I'm using in the application. All of them are stored here. Now, why do I do this? This allows me to use Google's ability to translate application languages directly. So if I have my strings defined in this strings.xml file, every string that is defined here will be automatically translated by Google when a person switches their languages. So you go into settings and let's give a live example of that. So I have all my text here. Let's go in here, settings, system, languages, add a language. Let's add Spanish, why not? Okay, and then let's select this as our primary language. All right, now let's go back in here. And let me reload this. Okay, no, this is a debug APK, so I don't think it's exactly linked up to there. uh, translation guidelines, so may not work in this particular example here. Let me go back here and change my language back. So in general, on your application, this is what it allows you to do. So let me give you an example of a published app. Let's head into calendar. So over here, all of this that you see is translated for you, and that's because you use something of this sort. Once you publish an app, you can also upload this file while uploading your application to the Play Store, and that allows you to have these languages, have your app explicitly support languages. So where's language again? Yeah, change it back. Awesome. Okay, so that is your basic example for accessibility features. Right. So let me close this up and all right. So we have covered all the details that we need, and that should get you up and running for completing all of the Android challenges that are there. We've successfully completed all the tracks, and the next step that we need to do is you guys need to complete your code labs, and then we will be sending out a form shortly where you can upload your screenshots of your entire code labs page along with the APK submission. So the APK submission allows you to enter a challenge that DSC, Google DSC hosts, and best apps are published and showcased on Google's own websites for DSC. So the deadline for this is 25th Jan. So I'm assuming that you guys have already started work on this. So that is all we have for this Android study jam session for this month, and we're looking forward to seeing a submission soon. Thank you.